Hey guys, in this video we're looking at Pythagoras' theorem and applications to problem solving. So life-related problems using Pythag, we're going to be able to solve them hopefully by the end of the lesson. So a little bit different to the basic Pythag lesson because this one implies that you know how to use the formula to find both short and long sides. So now we're looking for the right angle triangle, so identifying one in a situation. Draw a diagram which helps you isolate the important information, use the theorem and then to solve, and then writing a concluding statement in the context. Now that is one of the things that always pulls a couple of students out, is that they forget to read the question properly and ensure that they are answering successfully the question, especially worded problems. So vocab, just a rehash on Pythagoras' theorem. It's the relationship between the shorter sides and the long side. So c squared equals a squared plus b squared. And we're also going to look at the assumptions. So assumptions in mathematics are circumstances believed to be true without proof. That essentially just means like you're essentially making up something that isn't necessarily given to you or verified. And this is generally because you need to make this assumption in order for the mathematics to work. So we'll talk more about them specifically to each, and they kind of are nuanced for depending on the situation, and some aspects of mathematics require more assumptions or than others. Okay, so using Pythag in worded problems. So it always helps to draw a diagram and label your sides. So you've heard of me using the maths toolbox, problem solving toolbox. Drawing diagram is one of them. So read the question, elucidate, so that means draw out what you can, the important information and what the question is asking you. So I'm going to grab a couple of highlighters here. I'm going to use my pink because I'm just going to find out what is actually my question asking me to do. So first thing I should be looking for is a question mark or like a what, where, how kind of why statement, and that will help you out with identifying what you need to do. So there's a whole lot of information, and I can straight away just by like grazing over it, I can see how far. So that is going to be my question. How far up the wall does the ladder reach? Now I'm going to use a different color and and pick out the important information that will help me help me answer how far the ladder is going to be. So a ladder is 4.5 meters long. So that tells me something there. Against a vertical wall, so that's more information there. The foot of the ladder, so the base is another way of saying that, is 1.2 meters from the wall. And then I need to also give my answer to 1 decimal place. So let's draw a diagram. I don't have a ruler on my thing. Actually, I have straight lines, so that would help. So here's my wall. I'm going to try and draw it as vertically as possible. There we go. I'm going to assume that is a straight line. It doesn't look like it to me, and I cannot get it straight enough, which is irking me. And then I'm going to draw a ladder. I'm going to use red for my ladder, just so we can see that it is slightly different. So here's my ladder, and that ladder is 4.5 meters long. So I'm just going to write that next to my wall, and we know that the ladder is 1.2 meters from the wall. So this length here is 1.2 meters, and it's asking us what is the length of this wall. Now before we get any further, where does the ladder go up to this wall? Before we go any further, we're going to make the assumption that we have to assume that the ground is perpendicular to the wall. That means it's 90 degrees. Now, if it wasn't 90 degrees, this would not be a right angle triangle, and we would not be using Pythagoras' theorem to find x. So we have to make that assumption. Otherwise, well, can't use Pythag, can't use do the maths. And I know a lot of you just be like, whatever, don't need to do the maths, but hey, math. So let's do some maths then. FSA. Before we get started though, draw a diagram, label your sides. So I'm going to use the red. To label my sides, right angle, identify it, identify the side opposite. This means that this is C. I've got 1.2, so I'm just going to call that B. Ooh, that's a funky B. And this is A. So using that, I'm going to write my FSA. So C squared equals A squared plus B squared. Substitute in 4.5 squared. A squared is unknown, or is X. So I should have used X there. X plus 1.2 squared. I get excited and I realize that I probably should leave myself some space. Okay, so using algebra, here we go. Let's go, and it's the short side that we're looking for, which means that we're going to have to do the subtraction one. So we're going to minus 1.2 squared from this side, and this leaves us with x squared, 4.5 squared minus 1.2 squared. Now you can put your square roots on top of that. Equals, so x equals, just put that into the calculator. Lo and behold, square root of 4.5 squared minus 1.2 squared. Oh, there we go. Equals 4.33. Okay, so I'm just going to write that down. 4.33. Making sure I read my question. It says to me, give your answer correct to one decimal place. So 4.33 is one decimal. Oh, sorry, Control Z. No, it doesn't want to do that. I'm just going to have to move down. Sorry. I'm coming to the edge of my writing space. So that equates to 4.3x. Then you would make sure that you are giving your answer back in the context of the question. So I've done my formulate, which was like draw my diagram. Should have been a bit more explicit with this. And also my assumptions. I've done my solve. Now I'm going to, I know that's, I'm evaluate and verify. I would look at that and be like, well, it's shorter than 4.5 because both sides are generally shorter. I mean, the two sides are shorter in length than C. That sounds pretty reasonable. And then I am going to communicate my findings. So it's 4.3 meters. So it would be, assuming, I'm just going to pause it so you don't have to watch me write. So there's my answer. So I've communicated, assuming the wall is 90 degrees to the ground. So I've restated my assumptions. The ladder reaches a height of 4.3 on the wall. So that's all we need to do because it's in the context of the word problem. So that is me using my problem solving method as well. Okay, so here we are. We've got another question. Road sign like this is shown in the form of an equilateral triangle. It's mounted on the pole from the ground. How far is the bottom of the sign to the ground? So let's go, wait, have I done that? Same colors. So how far the bottom of the sign to the ground is the question that's being asked. And the green is the important information. So road sign, there's some important information. 7.6 meters, centimeters. Mounted on a pole, 2.5 meters long. And we have an equilateral triangle. So that is our important information. So now this is a little bit more complex, and this is where problem solving needs to come in. Like, think about a strategy you're going to do. So what we're going to do is, I know that I have this sign here. It's an equilateral triangle, which means that this is 76, this is 76, this is 76. So they're equal sides. However, they are not right angle triangles. To find a right angle triangle, I could fold this in half. So if I go dot, 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 that's not the best color. Let's go a yellow, see if that helps. Oh yeah. Down the middle here, and it's not going to help. That gives me a right angle there. Now, if this is 76 centimeters in length, I've gone halfway down, it's going to be half. So I need to find, I'm going to assume that assume that the pole is attached to the top of sine. So if you're like looking at the back of it, here's the pole and the sine is attached directly to the pole there. And then we're looking for the remainder of this pole. So this is our x. I'm just going to move down a bit. And the pole is 2.5 meters. Ooh, that's why we have straight lines. 2.5 meters. So I'm looking for the difference between the height of my sine and how far it is from the ground. So to do that, we need to do a few things. We need to, one, work out height of sine, and two, we need to find difference. So I'm going to call the height of the sine S, find the difference, and that'll give us from the ground. So find the difference from 2.5 minus S equals the x that we're looking for. So that is what we are doing. So the first thing I'm going to do is 76 divided by 2 gives us 38 centimeters. Now that I have that, I'm going to redraw my triangle here. This is 38, this is 76. I'm looking for S, so assigning my C, B, and A. And just so you know, and then we're going to go FSA, C squared equals A squared plus B squared. Oh, I haven't given myself much room, but that's okay. C squared is 76 squared. A is S squared plus 38 squared. Using my algebra, so last thing I do is add. I'm going to subtract and write that out. So it's going to be 76 squared minus 38 squared equals S squared. Find the square root of everything. S equals, and put that into your calculator. And here's what I prepared earlier. Gives us 65.82 centimeters. Now this is something you need to consider as well. The pole is 2.5 meters long, and this is in centimeters. So you might want to do a conversion. One thing has to be converted. While I'm already here, I'm going to convert this. So S equals 0.6582 meters. So I've done that, so dividing by 100. Okay, and then I'm going to find, so that's find the height of the sine, so that was like number 1. And step 2 is find the difference. So we're going to find 2.5 minus S equals X. Substitute in 2.5 minus 0.6852. I've written it wrong. Sorry about that. 582 equals x. That's bothering me that that's not lined up. Yours should be. And x equals, again, something I prepared earlier, 1.8418. And then I'm going to round. So this is 1 decimal. I'm going to give my answer back as a 1 decimal. So once I've got my answer there, responding back in words, including my assumptions. So I'm just going to write that out there. So I have checked my work. So I'm saying, how far is the bottom of the sign to the ground? There it is, 1.8 meters from the ground. Does it make sense? Well, yeah, 2.5 is pretty high up. The sign's 65 centimeters in height. Subtracting that, it leaves me with 1.84, which is kind of like a really tall person. And that sounds reasonable. And then I'm going to write my final statement. So I'll do that. So there's my final statement made with the assumption and my answer relating back to the question, or answering the question. There's some problem solving and reasoning problems here. If you ever get stuck, draw a picture, identify your right angle triangles. All right, cool. Thanks, guys.